Welcome to the Explainer. Look, if you work with Kubernetes or large-scale distributed systems, you know the absolute pain of flying blind during an outage. Stop scrolling through thousands of raw logs. Today, we're jumping straight into the ultimate troubleshooting arsenal for LogQL. We are going to fix that blind spot right now. We all know what it's like to blindly scroll through endless text logs, hoping something jumps out. But here's the reality. 90% of your daily support tickets can be solved by just 10 specific queries. We are going to cut right through the noise so you can start resolving incidents in seconds, not hours. So we're going to treat this explainer like a live coding session. We'll be skilling from basic label matching all the way up to advanced rate aggregations. Just imagine we're sitting right inside Grafana Play at play.grafana.org, hooked up to a preloaded Loki data source, and we are ready to hunt down some bugs. Okay, let's dive right in. LogQL is Grafana Loki's PromQL-inspired query language, and the absolute most crucial thing to remember is that every powerful LogQL search has to start with the foundational log stream selector. It's the mandatory first step that drastically reduces the sheer amount of data your system has to scan. And that brings us perfectly to Query 1. This introduces that mandatory first step, targeting specific log streams using exact equality operators. By opening up curly braces and specifying our labels, like app equals billing service and environment equals production, we instantly narrow down the noise. What's really cool here is how instantly our environment narrows down. We aren't boiling the ocean or querying the entire cluster anymore. We're isolated to just our production billing service. Honestly, this is exactly how you prevent your queries from timing out when things hit the fan. Let's move on to queries 2 and 3 and see how this builds. Once you select a stream, you use line filters. So here we're using the pipe equals operator to find lines containing the exact word error, and then using the pipe not equals operator to strip out those annoying health check logs that always seem to clutter up the view. And boom, our results immediately show just the critical API errors we actually care about. The health check noise, completely gone. These filters execute from left to right, progressively narrowing down the results until you're left with exactly what you need. But wait, what if your developers log error in lowercase in one microservice, but error in all caps in another? Query 4 is an absolute lifesaver here. By using the pipe tilde regex match operator, followed by the question mark I flag in parentheses, we force a completely case-insensitive search. This brilliantly illustrates how just a single regex string catches every weird variation of the word. You've got a capital E, all caps, all lowercase, it grabs them all. It saves you from writing 5 different clunky filters for the exact same underlying issue. So check out this comparison. Chaining multiple contains filters together? That's the slow way. If you want to search for several different error states at once, Query 5 is your blazing fast alternative. Just use that pipe tilde regex operator with an OR statement, which is that vertical bar sitting between error, fatal, and warning. Okay, it's time to level up. Query 6 introduces parsing. If your logs are written in a structured format like JSON, simply adding the pipe JSON command extracts all those hidden fields and instantly turns them into LogQL labels. From there, we can do actual mathematical comparisons, like filtering for requests where the duration is greater than 1 minute. This is huge because it forcefully extracts structured data from raw text right at query time. Suddenly, we have distinct, highly usable columns for duration, status, and path. This is the exact stepping stone that makes complex metric analysis possible. And here is that metric analysis. Query 7 takes us from simply reading logs to actually generating metrics on the fly. By wrapping our entire stream in a rate function over a 5-minute time window, using those square brackets, we can instantly detect system throughput. So instead of spitting out lines of raw text, the results transform into a clean time series metric visualization. This shows you the exact number of log entries per second. It is absolutely perfect for capacity planning or spotting when a sudden spike in traffic is hammering your service. Now, Query 8, this one right here is a support engineer's dream. We are combining everything we've learned. We parse the JSON, calculate the read over 5 minutes, and then use the PromQL-style aggregation function SumBy to group those exact rates by their HTTP status code. Instantly, we get a beautifully aggregated breakdown of success versus failure rates across the entire Nginx service. You don't have to guess anymore. You immediately know exactly how many 200s, 404s, or 500s your system is throwing every single second. Need to find the noisiest endpoints that are dragging your system down? Query9 uses the top K function to automatically extract the top 10 most active paths over the last hour. This instantly surfaces your highest traffic endpoints, completely bypassing the need to manually tally up millions of log lines. If there's a weird anomaly or some rogue bot just endlessly hitting a specific endpoint, it is going to pop right to the top of this list. All right, here we go. Let's dive into our final boss fight scenario. Picture this. It's 2 a.m. on a Saturday. You just got paged because there are intermittent 500 errors on a specific API service, and it's only been happening for the last 15 minutes. How do you find the root cause without manually tailing a waterfall of logs? Well, we build Query 10 step by step. Step 1, the stream selector isolates the API service. Step 2, the JSON parser extracts the labels so we can filter for exactly status 500. And step 3, we wrap the whole thing in a rate aggregation over a 15-minute window grouped by the API path. And here it is, the elegant 3-line LogQL query that pulls our entire progressive arsenal together into one single powerful command. It's clean, it's efficient, and it leverages the absolute core strengths of the Loki architecture to do the heavy lifting for you. Our results immediately isolate the true culprit. We can clearly see a massive error spike specifically happening on the checkout endpoint. What used to be an hours-long wild goose chase in the middle of the night is literally solved in seconds. Remember, mastering functions like rate and count over time doesn't just make you faster, it fundamentally shifts your workflow. It transforms you from a traditional log reader into a highly effective data analyst. You aren't just skimming text anymore, you are querying telemetry. Armed with this cheat sheet and these 10 foundational queries, you can now slice through massive telemetry data sets the second an incident occurs. You have the tools. So the real question is, what custom query will you build to conquer your next alert? Thanks for joining me on this explainer, and I'll catch you next time.